Okay, so let's jump right in. Have you ever just stopped and wondered about the hidden rules that, run everything? We're going to start with a question that seems super simple, but it actually took humanity centuries to get the right answer.
For the longest time, the answer seemed obvious, right? You kick a ball, it rolls for a bit, and then, well, it stops. You coast on a bike, and eventually you stop. It just kind of feels like running out of steam is the natural order of things.
I mean, this was the accepted wisdom for ages. The idea that all motion eventually stops because objects just want to be still. It makes a certain kind of intuitive sense, doesn't it? Everything seems to wind down on its own. But get this, that totally intuitive, simple idea was completely 100% wrong. And the real story, the one figured out by brilliant minds like Galileo and Newton, is just so much cooler. So let's play detective for a bit and uncover the real rules of the universe. So the first major clue in our investigation was a total game changer. Instead of thinking that things just want to stop, scientists realized that any change in motion, whether it's starting, stopping, or turning, it needs a cause. Something has to be responsible for it. And that something is what we call a force. This became the prime suspect in our little detective story. It's the invisible agent behind every single change. We can't actually see the force itself, but we see what it does everywhere. Kicking a ball, stretching a rubber band, even just pulling open a drawer. And here's the big twist. That ball doesn't stop because it wants to. It stops because of invisible forces like friction with the ground and air resistance literally pushing back on it. See, it turns out objects only change what they're doing when an unbalanced force comes along and makes them. Okay, so we've got our prime suspect, force. Now we need the rule book it plays by. And lucky for us, a guy named Isaac Newton basically wrote the whole thing down. You can think of this as the law of laziness. Seriously, objects are perfectly happy doing whatever they're already doing, whether that's sitting still on a table or cruising in a straight line. They resist any change to that state, and we call that resistance inertia. And this little trick, it shows inertia in action perfectly. The card gets a force, so it zips away. The coin doesn't, so its inertia, its laziness, keeps it right where it is, just for a split second, until gravity takes over and pulls it straight down into the glass. It didn't want to move with the card. Now, this one, let's call it the law of oomph. It's a super simple but incredibly powerful little recipe that connects force, an object's mass, and how much its motion changes, what we call acceleration. Basically, the harder you push something, the faster it speeds up, and the heavier something is, the harder you have to push to get that same result. This is exactly why a train has so much more inertia than a bicycle. You can give a bike a tiny push and get it rolling pretty easily. But try to give that exact same push to a train, forget about it. You won't even see it budge. Its enormous mass means it resists any change in its motion, way more. This one is the cosmic pushback, and it reveals something fundamental. Forces never, ever exist alone. They always come in pairs. If you push on a wall, that wall is pushing back on you with the exact same amount of force. So, here's the crucial point. While the forces are equal and opposite, they act on different objects. The gun pushes the bullet forward, and at the same time, the bullet pushes the gun backward. But since the gun has way more mass than the tiny bullet, its resulting acceleration backward is much smaller. Same force, totally different effects. All right, now this is where the story gets really big, because these rules don't just apply to things here on Earth. There's one force in particular that reaches across the entire cosmos. Newton's genius was all wrapped up in this one question. You know the story. He sees an apple fall, and he starts to wonder, could the very same force that pulled that apple to the ground be reaching all the way out into space, keeping the moon from just flying away? And the answer was a resounding yes. This revealed a stunning truth. The rules of motion weren't just for Earth. They were absolutely universal. You have gravity, I have gravity. This computer screen has gravity. Everything with mass is constantly, gently pulling on everything else. It's mind-blowing. And just look at the payoff from that one idea. Suddenly, a single, elegant law explained things that seemed completely unrelated before. From why we don't float off into space, to the majestic dance of the planets around the sun, it all came down to one universal rule. But this leads us to another question, right? If force is the agent that causes all this change, what gives it the ability to do that work? What's the motive behind all the motion?
While the motive is energy, you can think of energy as the currency that pays for every single push, pull, and movement in the entire universe. If you want to do work, which in physics just means applying a force over a distance, you have to spend some energy.
And this energy comes in two main flavors, mechanically speaking. There's kinetic energy, which is the energy something has just because it's moving. And then there's potential energy, which is energy that's all stored up, ready to be used, like in a stretched rubber band or an object held way up high. But here's the really crucial part. The total amount of energy in a closed system always stays the same. It can't be made or destroyed. It just changes its costume. It can transform from potential to kinetic and back again, but the total amount is always conserved. Let's look at an example. So picture an object held high up in the air. Right now, it's not moving, so its kinetic energy, its energy of motion, is 0. But because of its height, it's packed full of stored energy, potential energy. Let's just say it's got 588 joules worth. Okay, now we let it go. As it falls, gravity does work on it, and that stored potential energy gets converted into the energy of motion. And right at the instant before it hits the ground, that whole transformation is complete. It now has 0 potential energy left, and all 588 joules have been converted into kinetic energy. The total amount never changed, it just swapped its costume from potential to kinetic. You know, we can actually see this whole story, force, motion, and energy, come together perfectly in something we experience every single day, sound. Just think about it for a second. A vibrating guitar string applies a force to the air around it. This force causes the air particles to start to move, which creates these waves of high and low pressure. That moving wave is a transfer of energy, which travels all the way through the air until it hits your eardrum. Sound is literally force creating motion that transfers energy. It's a perfect little miniature of the rules that run the whole universe. It's pretty incredible when you think about it. The same few fundamental laws describe a falling apple, orbiting planets, and even the sound of my voice right now. It really makes you wonder, what other simple, elegant rules might be hiding in plain sight, just waiting for us to figure them out?